This is an IGCSE worksheet for probability, worksheet number 2. I've already uploaded number 1. It basically has probability of simple combined events and conditional probability. Complete the Venn diagram. This piece of information is not useful for now. This is useful. 3 say they do not like English or mathematics, so 3 is going to be out here because 3 students do not like either of those subjects. 33 say they like English. Now this is a little tricky. When they say English, just English, this entire circle represents English. However, they haven't mentioned the part that's overlapping. The overlapping part represents the number of students who like both English and mathematics. We're going to mention them as X. The remaining is going to be 33 minus X. Similarly, when they say 42 like mathematics, the entire circle represents mathematics. However, this part, the number of students who like both English and mathematics is not given. So the remaining is going to be 42 minus X. This is where we go back to this piece of information, and this is useful for us now. We are going to add all of these values together. 3 plus 33 minus X plus 42 minus X, and we are going to say this entire value is equals to 50 because 50 students are being asked whether they like the subject or not. We can start cancelling out, adding things together. Minus X plus X cancels out. 50 is equals to 36 plus 42 minus X. Now if you add these two values together, I am not going to rely on mental math. 36 plus 42 gives us 78, and 50 minus 78 gives us negative 28. Since we've got negative signs on both sides, that cancel out, and X is 28. Now what does this 28 represent? This 28 represents this value. Wait, let me write down the new values that we've just found out in red. So X is represented by 28. So 33 minus 28 is going to give us 5. And 42 minus 28 is going to give us 14. So when the question says complete the Venn diagram, this is the final solution. 3, 5, 28 and 14. This gives you 2 marks. Now the question says the student is chosen at random. Find the probability that the student likes English and likes mathematics. English and mathematics is represented by this part of the Venn diagram. This has 28 students. 28 over a probability is always calculated out of the total 28 over 50. You can also simplify it or write this down as it is. 2 students are chosen at random. Remember, this worksheet is about combined events. There's an event, and just right after that there's another event following that. 2 students are chosen at random. Find the probability that they both like mathematics. The probability of selecting a mathematics student and then another mathematics student. The probability of selecting a first mathematics student is obviously, how many mathematics students do we have? 42. So this is going to be 42, not 14. 42 by 50. Now probability of, since 1 is gone, probability of selecting another mathematics student, there are only 41 left, and the total number has decreased as well because we have selected 1 out of them. 42 into 41 gives us, let me do that in front of you on a calculator. 42 into 41 is 1722. 50 into 49 is 2450. And if I were to write that, this will come out to be 123 over 175. That's your final answer. 1, 2, 3, 4, 5. One part D is a tricky question. Let me write that down. This is extremely tricky. It's playing on words. The question says 2 students who like English are chosen at random. Now this is very important. Up here it says 2 students are chosen at random. When they say 2 students who like English are chosen at random, what is the total number of students who like English? 33. The denominator is not 50 anymore. So probability that a student likes English and also likes mathematics. So I'm going to write probability of English, mathematics, and another student who likes English and mathematics. So what is the probability of me selecting a student who likes English and also mathematics? Remember, it's 28. 28. This is where students usually make a mistake. 28 out of a total of the sample space that we're selecting it out of is only the number of students who like English. Students who like English are chosen at random, and means multiply 27 by 32. Why? Because once we've chosen a student who likes English and mathematics, there's one less student from the group who likes English and mathematics. Instead of 28, second time around it's going to be 27, and the total group of students who were 33 who liked English are now going to be 32. Second time around it's going to be 28 into 27 and 27 over 32. So that simplifies to, let me solve that on a calculator for you. So 28 into 27 gives us 756. 33 into 32 gives us 1056. Now what you're supposed to do, look closely, 756 divided by 1056. 756 divided by 1056 gives us 63 by 88, and that is your answer. Question number 2. A bag contains 3 blue buttons, 8 white buttons, and 7 red buttons. That's a total of how many buttons? 11 plus 5, that's 16 buttons in total. 2 buttons are picked at random from the bag without replacement, means you are not placing it back. Find the probability that the 2 buttons are either red or both white. So we've got probability that both are either red, probability of a red and a red, or probability of white and a white. So what is the probability of me selecting red buttons? 5 out of a total of 16 and 4 out of a total of 15. Now the question has been reset. Why? Because you fulfilled the first condition, that was both should be red. Now what does the second condition state? That they both should be white. In order for us to do that, or means plus probability of white is going to be, how many whites do we have? We have 8 over 16 into 7 over 15, because the second time around you're going to pick up a white button. The first one is gone, right? Out instead of 8 you have 7 now, instead of a total of 16 you have 15 now. When you solve that, you have 20 over 16 into 15 gives us 240 plus 56 over 240 again, and let's get the answer for this. 16 into 15, 20 plus 56 is 76 over 240, and I'm pretty sure we can simplify this. 76 divided by 240 gives us 19 over 60. That is the answer. Question number 3 says the diagram shows 5 cards. 2 of these cards are taken at random without replacement. Find the probability that both cards show an even number. How many evens do we have? Even and even. So what's the probability that both cards show an even number on the first one and even number on the second row? So on the first row we have 2 options, 2 and 4. So we have 2 out of a total of 5 options, and means multiply. Now that one of them is gone, how do we know it's gone? We just selected it, right? This 2 represents probability, not quantity. What's the probability of getting probability of getting an even number on the second row? Now we only left, imagine we selected 2. By the way, this 2 does not represent the actual 2 that's up there. This 2 represents the quantity. So we've selected the 2. There's only 4 left. That's only 1 card. 1 out of a total of 4, because since the 2 is gone, the total has also dropped. So it's 2. 2 into 1, it gives us 2. 2 divided by 20, and that simplifies to 1 over 10. Or you can also write it as 2 by 20. Malik goes to a shop every day to buy bread. On any day, the probability that Malik goes to a shop in the morning is 0.7. If he goes in the morning, the probability that there is bread for Malik to buy is 0.95. So there are two conditions. He goes in the morning and that there is bread. If he goes later, the probability that there is bread for Malik is to buy 0.6. Now the probability drops since he goes later in the market, later in the day. Calculate the probability that on any day there is bread for Malik to buy. The probability of Malik going in the morning and then there being bread for him, right? Let's write it close together with no commas. He's going in the morning and then there's bread. Or probability of him going in the morning. So no, he's not going in the morning now. He's going later in the evening, and then there being bread for him is B. The probability of morning and bread is 0.7 into probability of getting bread, it is 0.95. Let me highlight that for you. That's one condition. We add that to probability of him going late. Probability of going in the morning is 0.7. So probability of going late is going to be 0.3. How do I know that? 1 minus 0.7. 1 minus 0.7. Okay, so probability of going late is 0.3. Now the probability of him getting bread is, once he goes late, is 0.6. So 0.7 into 0.95, that's 133 by 200, and 0.3 into 0.6, that's 9 by 50. 9 by 50 plus 133 by 200, that's 169 by 200. Or you can also present it in decimals. Let's keep it in decimals since the entire question is in decimals. That's 0.845. Question number 5. In a class activity, all the 15 students wear hats. So there's a total of 15 students and all of them are wearing hats. 7 students wear red, 6 green and 2 white. One of these students is chosen at random. Find the probability that student wears a red hat. Students with a red hat were 7. There's a total of 15 students. Simple. That's your answer. 2 of the 15 students are picked at random. Now it's the probability of combined events. 2 events. What is the event? The event is that the two students wear hats of the same color. Same color. So it can be a student who's wearing a red hat, 2 students who are wearing a red hat, probability of a red and a red, or wait, let me write down the statement in English and then we're going to compare it to a statement in mathematics. Probability of a green and green, or we can have a probability of student wearing a white hat. I'll explain it again. We're selecting 2 students out of a total of 15, right? The probability that 2 students, the ones we're selecting, are wearing the same colored hat. So it can either be one student we select who's wearing a red hat, another student we select who's wearing a red hat. Now we reset the experiment, we send them back. Now, because we once selected them, we selected red. Now we're studying the probability of getting 2 students at random, one after the other, who's wearing green. So we call out one student and he happens to be wearing green hat. Call out another student who happens to be wearing a green hat. We send them back inside the class. Now we're trying to study the probability of getting 2 students, one after the other, who are wearing white hats. So what's the probability of wearing a red hat? 7 by 15 into 6 by 14. Since the question has been reset, or means plus, now the probability of selecting a green student who's wearing a green hat. Students who wear green hats are 6 by 15 into 5 by 14, or means plus. Now we're studying the probability. We send them back, by the way. Now we're studying the probability of selecting 2 students at random, back to back, who are wearing white hats. How many students wear white hat? 2. So 2 by 15 into 1 by 14. If and when we add that, we should get, if I'm not wrong, 37 by 105. That is our answer. You can plug that into a calculator. Now 3 of the students are picked at random. Find the probability that at least 2 of these wear red hats. Now in my lesson that I've recorded on YouTube, it's in the playlist for probability. Whenever we have 3 components, what do we make? A tree diagram. So 3 of the students are picked at random. Find the probability that at least 2 of the students wear red hats. Now this is pretty tricky and we will not be able to solve this until unless we make a tree diagram. This is our first pick. How many marks is this? 4. No wonder. That's our second pick. And the third pick is going to be even longer. I was not expecting that. Anyways, find probability that at least 2 of the students wear red hats. Now what is the probability of us selecting a student who has a red hat at the start? 3 hats, red, green and white, right? So let's label these as red, green and white. Similarly, red, green and white, red, green, white, red, green and white. This is kind of like a storyline. So once we're selecting the first branch and connecting it right to the end like this, that's the first storyline. Now let's label the rest of them as well. Red, green, white, red, green, white. This is going to take some while. You can forward the video. Find the probability that at least 2 of these 3 students wear red hats. 2 of these 3. So let me take out a color which would not mess up. Here we go. At least 2 of these 3. 1, 2, 3. If they're saying at least 2, we can select students more than 2 who are wearing red hats. So all 3 of them, if they're wearing red hats, that is at least 2 as well. Second branch is RR, red, red and green. We have at least 2 students wearing red hat, or red, red and white. So all first 3 branches satisfy the condition. Let me choose another color now. At least 2, so red, green and red. In this path we have at least 2. Red, green, green doesn't count. Red, green, white, no. So that's only 1 in the second set of branches. Let's go to the third. Red, green, red. This path also has students, at least 2 students who wear a red hat. What else? No other in this path. Then we have, let me choose another color now. Here we go. We have green, red and red. In this path we also have 2 reds. Do we have another path for this? Green, red, green, red, white, no. Green, green, red, green, 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 white, red. Green, white, green, white, white, nope. White, red, red. Here we go. We've just found another path. White, red, red. White, red, green, white, red, white, green, red, white, green, green, white, green, white, red. So all the colors that we've come up with over here, all the branches, these are our answer. Now how do we get that number? This is going to be, since it's a lengthy question, this is going to include multiple steps, but you don't have to worry about that. So the probability of selecting a red from the first one was 7 by 15, then 6 by 14, and then on the third try it's gonna be 5 by 13. Which line am I referring to? I'm referring to this first yellow line. So red, red and red. Now let's go on to the second yellow line. Let me mark that for you, this one. So this was probability of red, red and red. Now we're doing probability of, this is or, probability of red, red and green. So what's the option? Probability of selecting red on the first is, let me color code it, is 7 by 15. The probability of getting red another time is 6 by 14. And then green. Notice green, the number green did not change at all. There's still 6. So we're following this path. I'll highlight it for you and then just erase it. We're following this path, R, R and G. So for this particular path, the number of students who wear green hats hasn't changed a bit. So that's gonna be 6, but now the total number of students is 13. Now let's study the third one, which is red, red and white. So we've got 7 by 15 into 6 by 14, and the students who wear white are 2 by 13. So we're done with all three yellow ones, yellow probabilities. Now let's move on to the green one, that's the fourth. So what's the probability of me selecting a red, a green and then a red? Probability of selecting a student who wears green, who's wearing a red hat is 7 by 15, this part. Now the student who's wearing a green hat after the first red one has been selected, green students are 6 out of 14. And now the students who are wearing a red hat, remember we only selected one student, it's still 6 out of 13. The number in the denominator keeps on dropping since we're selecting one student every single time, but the categories sometimes do not change. For instance, we selected another red student after selecting a red student at the start. Usually you're expecting a number 5 over here in the numerator, but it's still 6. Why? Because you only had selected up until this time only one red student who was wearing a red hat had been selected. So let me remove all the highlighted paths that we're done with. We're done with this, we're done with this, we are done with this one, and we're also done with this green part. Right? We are left with the blue now. So red, white and red. Probability of selecting a student who is wearing a red color is 7, and then a white is 2 by 14, and then another red is 6 by 13. So we are done with this blue as well. Purple to go, green, red, red. What is the probability of selecting green students wearing a green hat? 6 by 15, and then a red. Red is still 7. Remember, that number didn't change. Now another, we're done with this part, we're done with this. Now a third red would be a third student who's wearing a red hat. Although the student we're selecting who's wearing a red hat is second because this one was green, remember? The first one was green. The second two are reds, these two. The probabilities of selecting red, I know this question is getting a little lengthy, but try to stay with me here. Now we're only left with a student who's selecting two red hats, but in this particular order over here. So what's the chance of selecting a student on the first try who's wearing a white hat? That's 2 by 15. Now a student who's wearing a red hat, 7 by 14. And now a student who's wearing another student, the student on the third try, that's the third pick, remember? Third pick, who is wearing a red hat, 6 by 13. We are supposed to add all of these together. And once you add all of these together, you end up with a number which is going to be, now this is going to take some while. Let's combine all of those fractions which look similar. So I'll color code them again for you. 7, 6, 5, 15, 14, 13. How many of these do we see? 7, 6, 5. There's only one of them. Now let's color code some other. 7, 6, 6. Here you go. 7, 6, 6. 7, 6, 6 in the numerator. 7, 6, 6. Why am I collecting them? Because I can simply write 2 into 7 into 6 into 6 over 15 into 14 into 13. In fact, not 2, 3, because there's 3 of them. 3 of them, right? What can I do now? There's only one 7 into 6 into 5. That's in green. And there's only, let's color code the rest. 7 into 6 into 2, 7 into 6 into 2, 7 into 6 into 2. Then there's another 3 of these guys. 7 into 6 into 2, 15 into 14 into 13. Now, what we can do, solve this. 7 into 6 into 6 gives us 252. 15 into 14 into 13 gives us 2730 times 3. 7 into 6 into 5 gives us 210, 2730, and 7 into 6 into 2 gives us 84. Do not forget to multiply it with 3 and 2730. One last step to go. 252 into 3, that's 756, plus 210, plus 84 into 3, that's 252 over 2730. 2730 luckily happens to be the LCM as well. 756 plus 210 plus 252, that's 1218, that 2730. And we can even simplify that and see, in fact divide that with the total number and see if we end up with this answer, 29 by 65, and that is perfect. I hope it made sense. I mean, that's a pretty long question and I hope you did not lose track of it.